In this lesson, we're going to solve exponential equations using natural logarithms. So the example says, use natural logarithms to solve the given equation for x. This first example is e to the x equals 5. So if you'll notice, the x is in the exponent. So what we're going to do is we're going to take the natural log of both sides because the base number is e. So we're going to go natural log of e to the x, and then on the same do the same thing on the other side, natural log of 5. Now, since we've taken the natural log of both sides, we can move this exponent into the front. And we know that natural log of e is equal to 1. So you have x times 1 equals natural log of 5. And then obviously x times 1 is just x. So you get x equals the natural log of 5. And we're going to go ln of 5, and you get 1.609. So you can list your answer as either ln of 5 or the decimal value 1.609. This next example says negative 7 times e to the x equals negative 42. So like a regular equation, the first thing we're going to do to be able to solve for x is we want to get rid of anything extra on that side. So we're going to divide both sides by negative 7. And so you get e to the x equals 6. And at this point, because your variable is in the exponent, we're going to take the natural log of both sides. Okay, so we're going to use properties of exponents that says we can take this x and we can move it to the front. So we're going to go x times ln of e equals ln of 6. And again, ln of e is 1. So you end up getting that x equals natural log of 6. So ln of 6 is equal to 1.792. You can list your answer as either natural log of 6 or the decimal form would be 1.792. This example says e to the 1/2 x plus 8 equals 12. So the first thing we're going to do is subtract 8 from both sides. Next, we're going to take the natural log of both sides because the variable has base e. You can bring down, by properties of exponents, you can bring down the exponent to the front. So we'll go 1/2 x times natural log of e equals natural log of 4. ln of e is 1. So now we just get 1/2 x equals ln of 4. To solve for x, we're going to times both sides by 2. And so you get x equals 2 natural log of 4. There's different things you could do with this. You could leave your answer like that. You could move the 2 to the exponent and write natural log of 4 squared or natural log of 16. Finally, I'm going to do the calculator value and get 2 natural log of 4. So you get 2.773. This example says e to the 2x equals 13. So there's nothing to get rid of around the e, so we're just going to take the natural log of both sides. We can move the power to the front. ln of e is 1. So now we just have 2x equals ln of 13. So we're going to divide both sides by 2. I'm going to write the divide by 2 in the front as a 1/2. So now we have x equals 1/2 ln of 13. So I get 1/2 natural log of 13 is 1.282. This example says 6e to the 4x equals 36. So the first thing we're going to do is divide both sides by 6. So you get e to the 4x equals 6. Now we'll take the natural log of both sides. this point, you can bring the 4x out to the front. And just like the previous problems, you have ln of e equals 1. So now we have 4x equals natural log of 6. And we'll divide both sides by 4. So we get x equals 1/4 natural log of 6. And let's also get that decimal value. Our last example is e to the 3x minus 5 equals 100. So there's nothing out in front or behind the e, so we'll just take the natural log of both sides. You're going to bring the entire power to the front. Because there's two terms in that exponent, I'm going to put parentheses around it and just leave it quantity times ln of e. So now we have ln of e is 1. Anything times 1, it's just itself, so you just have 3x minus 5 equals natural log of 100. So at this point, we're just going to isolate the x. We're going to go ahead and add 5. So we have natural log of 100 and then plus 5. And finally, we're going to divide both sides by 3. So I'm going to put the 1/3 in the front. Make sure you don't add these together because it's natural log of 100, then plus 5. So just leave it like this. And then again, we're going to get a decimal for this. 1/3 times the quantity, natural log of 100. Make sure you close the parentheses so the calculator knows that you just want the natural log of 100, and then we're going to add our 5. So you get 3.202.